Roughly 13.8 billion years ago, what we know as our universe was born with a sudden and immediate start, known as the Big Bang. What caused this sudden event is still not known. What we do know is that in less than a second, the universe was born in a very small size, and it was very hot. It started cooling and expanding at an extremely fast rate. In the very beginning, our universe was just 1/1000th the size it is today. We can think of everything we know about our universe having all fit into this tiny object, the size of a peach, or even smaller. We can go back to about 10 to the negative 43 seconds in time to a stage known as the Planck Epoch. This is basically known as the beginning of time. Following this, over the next second, many things happen, including the point that gravity begins and particles begin to be created. Electrons and neutrons form in large numbers. The universe cools off to a sun-tanning temp of 10 quadrillion degrees. By 1 second of age, the universe has cooled to 1 trillion degrees, which allows for protons and neutrons to begin forming. Over the next 20 minutes, the universe cools to 1 billion degrees, allowing atomic nuclei to form for simple elements such as hydrogen, helium, and lithium. The photon, or radiation era, lasts from 3 minutes to 240,000 years. From 240,000 to 300,000 years, the temperature has fallen to just 3,000 degrees. Ionized hydrogen and helium atoms are able to take hold of electrons, which is called recombination. Electrons are now bound with atoms, and the universe becomes transparent to light. During the end of this period, the universe is a foggy mess of hydrogen and helium and leads us into the Dark Ages, which lasts from 300,000 years to 150 million years. At around 300 to 500 million years, pockets of gas become more compressed from the force of gravity. They end up becoming very hot and trigger nuclear fusion reactions with hydrogen atoms and create our first stars. During this time, large volumes of matter collapse and form more stars and even galaxies. 8.5 billion years following the Big Bang, our solar system, the Milky Way, is born. During the time the Milky Way is being created, a cloud of gas quickly forms into a giant star we now know as our Sun. Gas and debris swirl about and create planets, moons, and asteroids. Earth is born during the time of the creation of the Milky Way and our Sun. It doesn't look quite like it does today, though. It was an extremely hot sea of molten rock. Heat was generated by high-speed collisions of space rocks, which collided over and over to form the planet. The giant impactor theory indicates that matter the size of Mars struck the Earth just after the solar system was born. This caused large volumes of extremely hot material to be ejected from the matter and the Earth. This orbiting material eventually stuck together and formed the Moon. While the Earth was still hot, water was still in gas formation on the Earth. As the Earth cooled to below 212 degrees, the water condensed into rain, which filled the basins in the Earth and became our oceans. This is what we know our Earth looks like today, following many supercontinents forming and breaking apart to become the 7 continents we know now. Our planet is still covered in 75% water. Our continents are still moving and shifting and will most likely look different hundreds of thousands of years from now. The Earth is made of several layers. We have the crust, which is the area we live on, the atmosphere, which is the air around and above us, made up of oxygen and nitrogen. There is the mantle, which is made up of molten rock, which is the source of magma for volcano eruptions. There's the outer and inner core, and of course there's also the hydrosphere, which is the water on the surface of Earth, including our oceans, lakes, and rivers. 3.8 billion years ago, the first life on Earth formed. Microscopic living cells, not yet described as plants or animals, began to evolve. 2.7 billion years ago, eukaryotes, which are cells with a nucleus, which became the main component needed for all higher life, including plants, animals, and even us, were beginning to form. 2.2 billion years ago, the ozone layer formed in our atmosphere, approximately 6.2 miles high. This ozone layer absorbs most of the UV radiation reaching the Earth from the sun. While the ozone has been around for over 2 billion years, it has only taken humans the last couple hundred years to destroy up to 20% of the ozone in some regions. 450 million years ago, Earth sees arthropods and plants begin to colonize. Arthropods include insects, spiders, and crustaceans. The plants that started forming some 450 million years ago included moss and liverworts. These were non-vascular plants and did not have deep roots. Many of the animals we still know today have been around for millions of years. The first string of elephants came around 26 million years ago, great apes around 18 million years ago, bovine about 15 million years ago, and large horses approximately 11 million years ago. Neanderthals and genus Homo, our closest descendants, came to be around 1.5 to 2.5 million years ago, the last of these dying out approximately 30,000 years ago. Fire was not invented by humans. It has been around for millions of years and is caused naturally by things such as lightning and lava mixing with fuels such as wood. However, it is believed that the genus Homo species of humans learned to use and control fire around 1.5 million years ago. Homo sapiens, our species we know as modern-day humans, first appeared in Africa 200,000 years ago. It is believed that Homo sapiens have evolved from earlier species of Neanderthals. The oldest skull showing signs of evolution was found in East Africa and is believed to be 195,000 years old. Since Neanderthals were still around until 30,000 years ago, it is believed that Homo sapiens and Neanderthals lived at the same time until the Neanderthals eventually became extinct and Homo sapiens became the exclusive form of human beings. Fast forward 13.8 billion years later, we are still seeing expansion and cooling in our universe. If you were to look at the universe on the day we started this class, you would see that it is different than on this, our final day of class. It was different yesterday, and it will be different tomorrow.